Now consider one question. If on the average rain falls on 10 days in every 30 days, obtain the probability that rain will fall at least 3 days of a given week. So here we can consider this as a binomial experiment or a Bernoulli's trial. That means we are interested in a number of days in which rain falls. From the previous history, it is given that what is the chance for obtaining a rain falling day? It is given that rain falls on 10 days in every 30 days. So if you are denoting the success as, what is our success? A rain falling day. So a rain falling day is taken as a success. Then it is given that what is the probability of a rain falling day? It is the probability of success P is equal to rain falls 10 days on every 30 days. So the probability of success is 10 by 30, that is 1 by 3. So the probability of failure, that is Q is equal to 1 minus P, that is 1 minus 1 by 3 is equal to 2 by 3. So for solving this problem using binomial distribution, we have the value of one parameter P is equal to 1 by 3. And what is the next parameter? See the question, obtain the probability that rain will fall at least 3 days of a given week. That means we are counting the number of rain falling day in a week of 7 days. So we can take n is equal to 7. Okay, and a random variable is counting number of days in which rain falls. Counting number of days in which rain falls in a week. So this is the binomial random variable which takes the values. What are the possible values? The values are 0, 1, 2, 3, etc. up to 7. So what is the probability mass function? Here the probability mass function fx is equal to ncx p raised to x q raised to n minus x, that is equal to 7cx 1 by 3 raised to x 2 by 3 raised to 7 minus x. Here the x is number of rain falling day in a week, that is 0, 1, 2, 3, etc. up to 7. So that is a probability mass function. So using this probability mass function, we can evaluate the required probability. Therefore, probability of obtaining at least rain falls in at least 3 days a week. Rain falls at least 3 days in a week. Rain falls at least 3 days in a week is equal to, convert this statement into the random variable notation. So we are counting the number of rain falling day in a week as the random variable say x. So at least 3 days in a week means that x is greater than or equal to 3. So p of x greater or equal to 3. P of x greater or equal to 3 means, so x can take the values 3, 4, 5, 6 and 7. So because we have 5 values, it is better to evaluate the complement, that is 1 minus probability that x equal to 0, 1 and 2. That is 1 minus of p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2 is equal to 1 minus of, what is p of x equal to 0? That is 7c 0, 1 by 3 raised to 0, 2 by 3 raised to 1 by 3 raised to 0, 2 by 3 raised to 7 minus 0, that is 7, plus 7c1, 1 by 3 raised to 1 into 2 by 3 raised to 7 minus 1, that is 6, plus 7c2, 1 by 3 square into 2 by 3 raised to 7 minus 2, that is 5. So after simplification, substituting into this probability mass function formula, we can see that this probability becomes 0.4296. See one more question. Out of 800 families with 4 children each, how many families would be expected to have 2 boys and 2 girls, at least 1 boy, no girl, at most 2 girls? What is the difference from the previous question? Here, instead of evaluating the probability, it is requested to find the number of families having 2 boys and 2 girls, at least 1 boy, no girl, and at most 2 girls. So in order to compute the number, first we have to find the probabilities of 2 boys and 2 girls in a family of 4 children. So here we can designate the success. What is the success? So we are defining the success as obtaining designate the success as obtaining either a boy or a girl in a family of 4 children. So suppose we are defining the success as obtaining a boy in a family. So what is the probability of success? The probability of success AP is equal to 1 by 2, and the probability of failure Q is equal to 1 minus P, that is 1 by 2. Here what is N? Because we are considering a family with 4 children, that means we are repeating it is equivalent to repeating the experiment in 4 trials, that is N is equal to 4. Then what is the binomial random variable here? Suppose the random variable is number of boys in a family of 4 children. And what are the possible values of this random variable? So the random variable can take the value no boy, exactly 1 boy, 2 boys, 3 boys, and 4 boys. Then what is the probability mass function? The probability mass function is probability that the random variable counting number of boys, suppose we have x boys, the probability of x boys is given by fx is equal to ncx p raised to x q raised to n minus s formula, that is 4cx 1 by 2 raised to x into 1 by 2 raised to 4 minus x, where x can take the value 0, 1, 2, 3 and 4. Now the first probability evaluation, probability of 2 boys and 2 girls. 2 boys and 2 girls. Converting into the random variable notation, that is the random variable taking the value 2, and what is p of x is equal probability of x is equal to 2, that is f of 2, that is 4c2 1 by 2 square into 1 by 2 raised to 4 minus 2, that is again 2, that is 4c2. What is 4c2? 4 into 3 divided by 4c2 evaluation, 4 into 3 divided by 1 into 2, that is 12 by 2, that is 6, 6 into 1 by 4 into 1 by 4, that is equal to 6 by 16. Now we have to compute the number of families having 2 boys and 2 girls out of 800 such families. So we take this capital N as 800, therefore required number is equal to capital N into the probability that the random variable taking the value 2 is equal to 800 into 6 by 16, that is equal to, we can cancel that 16 with 800, that is 50 into 6 equal to 300. That is, out of 800 families with 4 children, in 300 families we can have 2 boys and 2 girls. The second part of the question, first we are evaluating probability of at least 1 boy. At least 1 boy in random variable notation is x is counting the number of boys in a family of 4 children. So at least 1 boy means x greater than or equal to 1, and x greater or equal to 1 is equivalent to 1 minus probability that x is less than 1, that is 1 minus p of x is equal to 0, that is 1 minus of p of x is equal to 0, 4 is 0, 1 by 2 raised to 0 into 1 by 2 raised to 4 minus 0. So that is 4 0 is 1, 1 minus 1 by 16. 1 by 2 raised to 4, that is 1 by 16, that is 15 by 16. And therefore the required number of families out of 800 families, required number, that is out of 800 families, we have to compute the number of families having at least one boy, that is given by 800 into probability of x greater than or equal to 1 is equal to 800 into 15 by 16. Cancelling 16 and 800, we get 50. 50 into 15, that is 750. Now probability of having no girl, it is equivalent to probability of no girl means all are boys in a family of 4. So x is equal to 4. X is equal to 4 is 4c4 1 by 2 raised to 4 into 1 by 2 raised to 4 minus 4, that is 0. So 4c4 is 1. So again this is 1 by 16. And the number of families, required number of families, out of 800 is equal to, so that 800 into probability of x is equal to 4, that is 800 into 1 by 16, so that is 50. So now the final probability evaluation, probability of at most 2 girls. Probability of at most 2 girls means in terms of boys it is at least 2 boys, it is equivalent to at least 2 boys. At least 2 boys in random variable notation, that is x is greater than or equal to 2. X greater or equal to 2 means x can have the value 2, 3 and 4. So p of x equal to 2 plus p of x equal to 3 plus p of x equal to 4. So we have already evaluated the first and third probabilities, p of x equal to 2 and p of x equal to 4. So this is equal to 6 by 16 plus this is 4 by 16 plus p of x equal to 4 is 1 by 16. So totally we have 6 plus 4 plus 1, that is 11 by 16 is the probability. Therefore required number of families equal to is equal to 800 into probability that x greater than or equal to 2, that is 800 into 11 by 16, cancelling 16 with 800, 50 into 11, that is 550. So this is the way in which we are solving some problems using binomial distribution. The first problem is about probability computation and the second is about some number computation after computing the binomial probability. Okay, thank you.